know, like you do it on the top and like manila folders, so they can put them on the top of ours.
Oh, I love
them. Yeah, with the prong things, where you hold them down.
All right. So, order of operations states that we need to square the inside before we square root the value. So, first thing you're going to do in number 1 is square the 3 and the 4. So, we want to square 3 and 4. So that this becomes the square root of 9 plus 16. And again, order of operations says that you have to square root the numbers added together before you square root. So you can't square root 9 and 16 separately. You have to square root the sum of 9 and 16. So it's the square root of 25, which is 5. Any negative number squared becomes 1. So negative 2 squared becomes 4. 8 squared becomes 64. 4 and 64 become 68. So now, what perfect square goes into 68? 8. Oh, wait, never mind. 13 is 4. So the square root of 4 and the square root of 17, because 4 times 17 is 64. So you get 2 square roots of 17.
Wait, 4 times 17 is 64.
Correct.
And why are we equaling that?
I mean 68. Sorry, 68. Thank you. Okay, 5 squared is 144 is negative 12 squared. So you add 144 and 25 together, and you get the square root of 169, which is actually a
perfect square.
4. Okay. 6 squared is 10 squared is, so the square root of 136. So what perfect square goes into 136?
Probably 36.
4 and what?
4 and 34.
Good. Square root of 4 is? 34 is what 2 bigger numbers multiplied together?
30. Never mind.
17.
Yeah, and?
2.
So are 17 and 2 divisible by any perfect squares?
No.
No. So that means we found the largest perfect square that went into it, and our final answer is 2 square roots of 34. Yes.
That's so rude.
Okay, what's x squared plus x squared?
2x squared.
Thank you.
Ha 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 ha.
Can I simplify the square root of 2?
No.
What's the square root of x squared, though?
2x.
X.
Oh.
It is even, so it becomes absolute values with root 2 left behind. Okay, when you square a whole parenthesis, you square both things in the parentheses. So that is like 3 squared, which is x squared plus 4 squared and x squared. Combined like terms, 9x squared plus 16x squared is We already said the square root of 25 is, the square root of x squared is always absolute value of x. Go ahead. Sorry. Okay? So again, all we're doing is kind of looking at order of operations. These are very similar if you're in physics to magnitude problems. So if you're not, you'll do them next year. It's just kind of a connection between the two. We are in 5-4. We are starting what we call complex numbers. So again, up to this point, you guys have learned what the real number system is. So the real numbers were the reals, the rationals, integers, whole, natural, all the jazz. Every once in a while, if you type in something on your calculator, you get this error code, and it says non-reals. We're going to talk about that error code today. We're going to talk about those answers. So, anybody know an example that would give your calculator a non-real? Yeah?
Square root of -1.
Yeah, square root of -1. That is the most basic complex number that we're going to talk about today. So, the complex numbers, by definition, are the set of numbers consisting of the imaginaries and the reals. Okay? Justice said the square root of -1. The square root of -1 is special. The square root of -1 has a value of I. So we're going to talk about that I today. So I is the principal square root of -1. It would look like this. I equals the square root of -1. We have what we call the imaginary unit, I squared, which is -1 as a number, no longer a complex. So we have the principal square root and we have the imaginary unit.
Is imaginary unit and imaginary number the same?
No. So the imaginary unit is the base I squared. The imaginary number is like I. Imaginary numbers are all the negative square roots in the world. So we're going to see some examples today where it's like the square root of -16 or the square root of -5. Those are all considered imaginary numbers. Good? Okay? So, like I said, we had what we used to call the real number system. Now we have this new number system called the complex. The complex numbers are made up of the real numbers and the imaginary numbers. So the complex numbers are made up of the real and the imaginary. So it takes on the form A plus BI. Takes on the form A plus BI, where A is the old real number and BI is the new imaginary. So the complex number system, here's our old real number system over here. This is what we used to know. This is what we talked about in chapter 1. We talked about the real numbers, and then we had the rational numbers and the irrational numbers. Now, we're going to introduce the imaginary numbers, or the non-reals, as your calculator will tell you. Let's look at some examples. What I want you to do is every single time you see a square root with a negative underneath, automatically write yourself down the I. So every time you have a square root with a negative underneath, automatically change it so it's I and whatever the numbers were under the square root. A negative on the outside and a negative on the inside do not cancel. What is the square root of 121? Okay, let's simplify this one step further. This is 11I minus 7. The square root of negative 18 becomes rewritten as I, square roots of 18 plus 7. 18 divides by what perfect square? 9. So the square root of 9 is 3. What was left behind when we took away the 9? 2. So it becomes 3I square root 2 plus 7. That 7 is being tagged along. It's just added, kind of like yesterday. The numbers outside got multiplied. They tagged along. Okay, square root of negative 25. Take the negative away by making it an I. Square root of 25 is... So what you'll notice, when I write all of these, where do I put the I? Do I put before the number or after the number? Yes, so when you write it, it's DI, number, then I, plus 7. What else do you notice about all of my I's? They're lowercase, and they got a little, like, curl on them. Add that tail. That tail is part of it. It's not just like the lowercase letter I. It's this imaginary I. It has a curl to it.
Think about it, J. So the like plus 7s just like it just goes.
They tag along. Yep. If they could be like anything. I just use 7 every time to make the point. Okay? Anybody remember what the definition of an additive inverse is? What's that mean? What do you think?
Like the opposite.
Yeah, it literally means the opposite. So if it says find the additive inverse of each complex number, we are literally going to find the opposites. So opposite of negative 7 is? Opposite of negative 9I would be? Opposite of negative 5I? Yeah, not trick. 5I. Opposite of negative 4? Oopsies. Opposite of 4? Opposite of negative 3I? Opposite of A? Opposite of BI? Curl those eyes, stop them, we're done. Okay, here's the part I think you like a little bit less. We're going to talk about what we call the patterns or the cycles of I. I has 4 values that we're going to ever write down. So if you see simplify the I, there are only 4 correct answers. Here's the nice part. I to the first equals I. You got an I and it's to the power of 1, it's I. On the front of our notes, what did we say I squared was equal to? -1. I squared is equal to -1 because what did we say I is equal to? Yeah. What happens if you take a square root and you multiply them together? So square root of -1 times square root of -1. The square roots technically cancel each other. If you had the square root of 4 times the square root of, well, 4 is a bad example because it's a perfect square. So you make it 2 and 2. Square root of 5, square root of 5. Go ahead and type that if you have your calculator out. Square root of 5 times square root of 5. What's it going to become? Any thoughts?
5.
Yeah. Because really, that's the multiplication property in reverse, right? It's like square root 25. Same with this. I squared is kind of like square root -1 times square root -1, which becomes -1. I cubed becomes I and I squared together. So what do we think I cubed is going to become?
-19.
Yeah. Don't even have to write the 1. I to the 4th is kind of like I squared times I squared, right? So what's -1 times -1? Those are the powers of I. So I told you it repeats, right? The pattern just keeps going. So I to the 5th would become what? I. Because it's going to be the same as I to the 1. Because it repeats every 4. So I to the 6th is going to become I to the 7th is like okay, I to the 8th is going to be like, because how do you get to 8? You add 4 and 4, right? So it's really like 1 times 1. Same with like 7. It's really kind of like I to the 4 times I to the 3. So I to the 3 is -I. I to the 4 is always 1. So what we're going to do to continue to simplify these is find powers of I to the 4 and then find the remainder. I'll explain that kind of as we do example 5. I to the 13. What is a power of 4 near 13 but less than it? 12. How many away from 12 is 13? So think of this kind of like I to the 12 times I. Any multiple of 4 is the same as I to the 4. I to the 4 is what? So that means I to the 12 is really 1. So I to the 13 is simply I.
Wait, so why did you put a 1 in front of it though?
1 times I is still I. Because I was proving that I to the 12 kind of became the 1. Like that's what happened to it. So 11. What multiple of 4 is less than 11? 8. How many more do I need to go from 8 to 11? I to the 8 is a multiple of 4. All multiples of 4 are really a I cubed is what? So I to the 11 is -I. And if you count through these, think about it. If you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, where do I end up in the cycle? So that's what's happening. It's just that who wants to count to 91? Like, do you know what I mean? You'd have to go 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's
Or you
a
can count by
lot of
fours.
counting. Great. So, instead of counting all the way by fours, we know every multiple of 4 ends me here. So what multiple of 4 is less than 91? Lower. Not 98. 88. So this is kind of like saying, okay, I4 is like I88. So then it's 89, 90, 91. So 91 is really, yeah. And from 88 to 91, you need a 3. I cubed negative I. You see in it? Okay, 244 is close to what multiple of 4? What'd you say? 40. I mean,
Is it 244 multiple?
yeah.
So it's just one.
So, like, even if you said 240, then you went 241, 242, 243, 240. So, I to the 244 is. Okay, I to the 10 would be what? Yep. Because it'd be like I 8, 9, 10. I 8. I never like said that before.
I can't wait to eat.
I 8, negative 1.
No one said anything back.
We're all like, okay, nice. Look, okay, I'm
It's like a stupid math
If-
thing, except you don't put pi afterwards because that's what's expected.
good one, Justice.
My day is next week. We will have sign-ups on Monday.
Wait, what?
My day is next Thursday. We'll have sign-ups on
So you
Monday.
get half Friday?
Are we eating pie?
This is my
I've never gone
first
to this
Friday.
privilege.
All right, well, we're celebrating Pi Day. Okay, I to the 6. You cannot combine the 6 and the 3 to make this I to the 9th. You have to add them separately. So I to the 6th became what? I cubed becomes,
Negative I.
so your answer is negative 1 minus I.
What if you got one that was like I to the 244 plus I to the 10th? Would you just put 0? Alright.
Yep.
It's just 1 minus 1.
Yeah. We're not going to finish the bottom of your notes today. We'll finish this tomorrow.